Hello, today we will discuss about how to minimize our transportation problem. Here you can see that I have taken one example from operations research book. I will link that this description below in comment section. So here the problem is that a plastic manufacturing has 1200 boxes of transparent warp in stock at one factory and another 1000 box at second factory. The manufacturer has ordered for his product for from the three different retailer in quantities 1000, 700 and 500 box respectively. The unit shipping cost in box from the factory to the retailer as below. So now we had given our problem to minimize our this objective function. X11 means this factory 1 to retailer 1, X12 means this factory 1 to retailer 2, X13 means factory 1 to retailer 3. So we have to minimize this function. 14 this X11, 13 X12, 11 X13 same as 13 X21, 22 and 23. Now since the amount of shipment from the factory cannot exceed supply, so we had given our this plastic manufacturer. So factory 1 this less than 1200 and factory 2 less than equal to 1000. And now we have shipment quantity this one means this factory 1 to retailer 1, factory 2 to retailer 2 greater than 1000. Here you can see that this quantity 1000, 700 and 500. Now we'll just write the Python code for that optimization method. So we'll use pulp for optimization of our problem. Now we'll import pulp for import everything. So now we'll minimize our problem. Problem is equal to LP problem. We had defined this problem maximization, not maximization, minimization of transportation cost, and we will minimize. LP minimize function is for minimization our problem. Now we will define our variable. X1 means factory shipment from factory 1 to 1, X2 means factory 1 to retailer 2. Same way X3, X4, X5 and X6. Now we'll define our objective function. 14 X1, 13 X2, 14 X1, 13 X2, 11 X3, 13 X4, 13 X5 and 12 X6. Now we'll constrain it. This is our constraint method. Problem, we have defined this our problem plus equal to. Now we'll define our constraint equation. X1 plus X2 plus X3 less than equal to 1200. Same way X4 plus X5 plus X6 less than equal to 1000. Same way we will define other parameter. Now we'll solve this. Status equal to prop dot solve. This is our function, so we'll input this function to this solve, and now this is status. It is means it will optimize or not, it will give our status. Now we will print this value. So by that printing value you have to wrote that command. You can find out pulp library how to wrote that, means how to give that value and all this thing. You can search simply pulp and it will give how to syntax is. So it is like just like that. So we will print all the value. So if we run this code, our objective value is means minimization of this problem. Transportation cost is 276 double zero, and our x value is 0, x2 is 700, x3 is 500, x4 is 1000. So if we check our value x2 plus x3, you can find that it is almost 1200. X4 plus x5 is 1000, so it is equal. Now x1 plus x4, x1 plus x4, it is 1000. Now x2 plus x5, x2 plus x5 700, and x3 is 500. So by that way you can verify our model. Thank you guys.